Experiment 5 Chemical Equilibrium. Learning outcomes. Number 1. Study the effect of concentration and temperature on chemical equilibrium. And number 2. Determine the equilibrium constant Kc of a reaction. Le Chatelier's principle. If the system at equilibrium is disturbed by a change in temperature, pressure, or concentration of one or more components, the system will shift its equilibrium position in such a way so as to counteract the effect of the disturbance. Result: effect of concentration in the formation of thiocyanoiron 3 complex ion. Iron 3 ions, the color is yellowish. When it reacts with thiocyanate ions, it will produce thiocyanoiron 3 complex, which is blood red. In our experiment, when we add 1 ml of 0.1 molar iron nitrate, our observation is blood red solution turn darker. Look at the picture. And when we add 1 ml of 0.1 molar potassium thiocyanate, the observation is blood red solution turn darker. And the last one, when we add 1 ml of sodium hydroxide, our observation is blood red solution turn yellowish, brown and rusty. Discussion Part A. Effect of concentration in the formation of thiocyanoiron 3 complex ion. When we add iron 3 ion, which reaction will be favored? Which way will the equilibrium shift? And what color will the solution go? This is the equation. Iron 3 ion plus thiocyanate ion, and the product is thiocyanoiron 3 complex. The disturbance is we increase the concentration of iron 3 ion. System respond by decreasing the added iron 3 ion as to re-establish a new equilibrium. Action is the equilibrium position shifted to right, and the effect concentration of thiocyanoiron 3 complex increases and concentration of iron 3 ion and thiocyanate ion decrease. Effect of concentration in the formation of thiocyanate ion 3 complex ion. When we increase the concentration of thiocyanate ion, the response is system respond by decreasing the added thiocyanate ion as to re-establish a new equilibrium. The equilibrium position shifted to right, and concentration of thiocyanoiron 3 complex increases, and concentration of iron 3 ion and thiocyanate ion decrease. Okay, when we add sodium hydroxide, what happens is sodium hydroxide decreases the amount of iron 3 ion because hydroxide ion react with iron 3 ion to form rusty brown precipitate of iron 3 hydroxide. The system responds by increasing the concentration of iron 3 ion as to re-establish a new equilibrium. The equilibrium position shifted to left, therefore concentration of iron 3 cyanate decreases. Concentration of thiocyanoiron 3 complex decreases, and concentration of iron 3 ion and thiocyanate ion increases. Result Part B. Effect of temperature on equilibrium. When hexa-aqua-cobalt 2 complex react with HCl, and it will form tetrachlorocobalt 2 ion. At room temperature, our observation is purple solution, and when the sample in ice bath, our observation is the purple solution turn pink. When the sample in hot water bath 80 degrees Celsius to 90 degrees Celsius, our observation is purple solution turn blue. Discussion part B. Effect of temperature on equilibrium. The formation of purple solution at room temperature shows the presence of hexachlorocobalt 2 complex and tetrachlorocobalt 2 ions at equilibrium. The disturbance decrease in temperature placed in ice bath, lowering the temperature, the action by releasing some heat to the system, favoring exothermic reaction and shifting the equilibrium position to left. The concentration of tetrachlorocobalt 2 ion decreases, and concentration of hexachlorocobalt 2 complex ion and chlorine ion increases. As a result, new equilibrium re-established and the solution turned pink. By increase in temperature, we place sample in hot water bath. The system tries to decrease the temperature by absorbing some heat to the system, favoring endothermic reaction and shifting the equilibrium position to right. The effect is concentration of tetrachlorocobalt 2 ion increases and concentration of hexachlorocobalt 2 complex ion and chloride ion decreases. So, new equilibrium re-established and the solution turned blue. Discussion part B. Applying the Chatelier principle, we can conclude that the system favors an endothermic process so as to counteract the added heat. Result part C. Determination of equilibrium constant. Antimony trichloride plus H2O will produce antimony oxychloride and HCl. Example, burette reading in milliliter, so volume of water added is 15.00 milliliter. By applying Kc equal to concentration of HCl to the power of 2 divided by concentration of antimony trichloride. Calculation part C. Determination of equilibrium constant. By referring to the balance equation, calculate the mole of antimony trichloride. 5 ml divided by 1000 times 0.5 molar, and we will get X mole of antimony trichloride. When we add 15 ml of distilled water, so the final volume is 5 ml plus 15 ml equal to 20 ml. And we can calculate the volume in liter. Thus, the concentration of antimony trichloride is X mole divided by Y in liter, and the answer is P molar. And then we have to calculate the number of mole of HCl equal to 5 ml divided by 1000 times 6 molar. The answer is a mole, and then the new concentration of HCl, A mole divided by new volume, which is Y liter, and equal to Qm. And step 3, Kc equal to concentration of HCl to the power of 2 divided by concentration of antimony trichloride equal to Q to the power of 2 divided by P. Exercise. Explain why the concentration of pure liquid and solid are excluded from the equilibrium constant expression for a heterogeneous system. Conclusion. The chemical equilibrium is affected by temperature and concentration, and Kc of the reaction is ... Thanks for watching.